next problem having been chosen from the book Modern Physics by Kenneth Crane. As usual, we first come to its statement. Okay, calculate the de Broglie wavelength of an electron with energy EF, where F is written as a subscript of E, standing for Fermi energy. Okay, in copper Latin name cuprum. Okay, denoted by Cu. Okay, and compare the value with the atomic separation in copper. Once again, calculate the de Broglie wavelength of an electron with Fermi energy EF in copper and compare the value with the atomic separation in copper. Okay, first we come towards several helping tools. Okay, which will be used in solving this problem. Okay, helping tool number 1, momentum of a photon P is equal to photon energy E over speed of light in vacuum C. Okay. Momentum of a photon P is equal to photon energy capital E over small c, that is speed of light in vacuum. This alternatively becomes equal to hf, where h is Planck's constant and f is the frequency, over c. C is same as described previously, that is speed of light in vacuum. This alternatively becomes equal to h over lambda, where lambda is wavelength. Okay, and h is Planck's constant as described earlier. Helping tool number 2 is also about rearrangement of helping tool number 1. Okay, helping tool number 2 says de Broglie wavelength of a particle lambda is equal to h over p, where h is Planck's constant and p is particle's momentum. This alternatively becomes equal to h over mv, where m is particle's mass and v is particle's speed. Okay, de Broglie wavelength of a particle lambda is equal to h over p, where h is Planck's constant and p is particle's momentum. This expression alternatively becomes equal to Planck's constant h divided by mv, where m is particle's mass and v is particle's speed. Dear students, now we move to helping tool number 3. Okay, some masses in energy units. Okay, entity mc square within bracket a million electron volt. Dear students, from this table value of electron is under consideration. Okay, we are not for the time being concerned with serial number 2, 3, 4, 5 of this table. Okay, we are only concerned with serial number 1, that is electron. Okay, electron mc square million electron volt is 0.511. 0.511 million electron volt, or equivalently if we write in terms of electron volt, then it will be written as 511 and 3 times 0. Okay, that is 511000. Okay, now we move to helping tool number 4, Fermi energies of some metals. Okay, dear students, here cuprum Cu, copper for copper, serial number 1, 2, 3, 4, 5, 6. Okay, at serial number 6 metal copperum Cu is given and its Fermi energy Ef is given in electron volt as 7.03. Okay, dear students, if we compare such a table in various books of modern physics like Modern Physics by Kenneth S. Crane, Modern Physics by Arthur Weiser, Modern Physics by Paul A. Tipler, Modern Physics by Andrew Rex and Stephen T. Thornton, Modern Physics by Randy Harris, Modern Physics by Moyer Moses, Raymond Survey. Okay, so that then if we compare such tables given in such different books, then we come to conclude that this value of copper, that is Fermi energy of copper, varies from about 6.9 to 7.5. Okay, from about 6.9 to 7.5, but currently we are following this table. Okay, so we will take Fermi energy of copperum as 7.03 electron volt. Helping tool number 5, in helping tool number 5, nearest neighbor distance nanometer and cohesive energy kilojoule per mole is given. Here at serial number 4, copper, that is copperum, is given. Okay, copper, crystal type FCC, face centered crystal structure. Okay, nearest neighbor distance 0.256. This is the value which we will compare about atomic spacing. Okay, we are concerned with this value. Okay, 0.256 nanometer, nearest neighbor distance 0.256 nanometer. This is the value with which we will compare our solution of this problem. Okay, as required in a statement. Okay, the helping tool number 6 is a comprehensive table of physical constants. From this table we may use several values. Okay, for example, we may use speed of light c, we may use one value is in this table also given, and in the previous table it was also given. Okay, electron mass me equal to 0.511 million electron volt over c square. Okay, moreover, value of hc as a combined result is also given. Okay, value of one atomic mass unit is also given. Moreover, E square over 4 pi epsilon naught, combined value of this is also given, 1.440 electron volt nanometer. Okay, now we come to solution. Solution is quite simple and short. In comparison with short solution of this problem, we have introduced sufficient helping tools. Okay, we know that momentum P is equal to E over C is equal to H F over C is equal to H over lambda. Okay, this implies that lambda is equal to H over P is equal to HC over PC. What we have done, we have multiplied and divided it by C. Okay, this all material is from helping tool number 1 and 2, in which momentum of a photon and de Broglie wavelength was described. Okay, lambda is equal to H over P is equal to HC over PC. Here in the denominator, in place of P, we have written 2m capital E. Okay, while C is as it is, okay, outside the under root sign. Okay, then when this c will be entered into the sign of under root, then it will become c square. Okay, because under root of c square is simply c, and so we can write this c as c square within the under root. Okay, this is just readjustment of this quantity figure. Okay, so dear students, from the table which we described as one of the helping tools, in that table value of combined value of Planck's constant and speed of light c, that is hc, was given, that is 1240 electron volt nanometer. Okay, divided by sign of under root into 2 into, in place of mc square we have written 511,000 electron volt. Okay, actually in that table 0.511 million electron volt was given in place of mc square. Okay, but here in place of a million electron volt we have used simply electron volt into E. What is EF? That is Fermi energy. It is Fermi energy, and its value is 7.3, is 7.03 electron volt. And about this Fermi energy, we had described that if we compare this value given in various books of modern physics like Kenneth S. Crane, Paul A. Tipler, Moyer Moses, Raymond Servais, Randy Harris, Stephen T. Thornton, Andrew Rex, etc., then this value varies from 6.9 to 7.5. Okay, but here, because we are following this table in which value is given 7.03. Okay, so we are following this. Okay, next, this is just simplification. Okay, nothing else. Dear students, we can see that within the under root sign, electron volt is coming twice. The benefit of this twice value is that this value will become in a single power outside the under root sign. Okay, so our result will be nanometer over electron volt. There is some mistake perhaps. No, yes, okay. Actually, dear students, electron volt appears twice within the under root, and it will appear only once outside the under root, and this once electron volt will be cancelled with 1 electron volt in the numerator. Okay, so our solution becomes 1240 electron volt into nanometer over 2680.42 electron volt. This electron volt will be cancelled with this electron volt, and our solution will be only in nanometer. That is, okay, our wavelength lambda will become equal to 0.4626 nanometer. 0.4626 nanometer. Next, within bracket we have explained a comparative arrangement, because kinetic energy is equal to half mv square and momentum p is equal to m into v, mass into velocity. This implies that kinetic energy becomes equal to p square over 2m, and hence p becomes equal to k2m. But here in this problem we are dealing with Fermi energy, so in place of k we will use E, simply E. Okay, or EF, Fermi energy, or simply E. Okay, so from here we can understand why this P has been replaced with 2m capital E. Okay, P P square will be equal to 2mk, and P, simply P will become equal to 2mk under root. But here in this problem k is E, so 2me under root. Okay, nothing else explainable. Okay, everything is quite clear like crystal. Okay, so dear students, here we say that from table we had seen that 0.256 nanometer is the nearest neighbor distance. Okay, so we can conclude that this value, that is value of lambda, that is lambda equal to 0.4626 nanometer, is comparable with this value given in the table. Okay, 0.256 nanometer. Okay, so this implies that comparable to the atomic spacing of copper. Okay, we were required whether it is comparable, so its answer is yes, it is comparable to the atomic spacing of copper. And this is the end of our problem, this is the end of our video. Till next video, Allah Hafiz. Okay.